All right, everybody, thank you very much for showing up in these high numbers to my talk on two total hype topics. Microservices and domain-driven design, I'd say on a hype scale, that should rank quite high. But what I found out studying a lot of, I would say, the ideas around microservices and the ideas surrounding domain-driven design is that the both of us are actually a really perfect fit together. And I elaborated on some ideas and put them into this talk, which I'm going to give tonight to you guys. Just a few words about myself. My name is Michael Plöd. I work for a company called Euregio. We offer software development, consulting, software architecture consulting, and some trainings as well. And I'm a principal consultant there, usually in southern Germany, but sometimes I'm also traveling around quite a bit, so I had a chance to be there tonight. If you want to follow me on Twitter, @bitboss is my handle, and I'll also publish the slides and stuff like that after the talk tonight, or maybe tomorrow in the morning, so you can have a reference to the slide deck as well as soon as I've published it. First of all, another disclaimer. Most of these ideas don't come from me personally. I'm not as smart as Eric Evans is, and I really have to give Eric and also Vaughan Vernon a lot of credit for writing these incredible books about domain-driven design. And what I've done in this talk, I've taken a couple of the ideas from the books, mixed them up with some personal experiences around that topic, and that's how this talk got together. So if you haven't read the books yet, that's a really good read. Also the books by Vaughan Vernon, very high recommendation from myself. So looking at domain-driven design and microservices, we will usually, when we dwell into some of these topics, find out that, for instance, DDD and microservices are about bounded context. So the bounded context, if you read any microservice literature, you will sooner or later stumble over the two words bounded context. But I think it goes way steeper than that. Yes, the bounded context is a very, very important concept for microservices, for building independent microservices. And basically, the definition of a bounded context is also something that gets referred to very often in the microservices world. But I think it goes ways further, especially when you have to deal with a grown application landscape. I mean, not everybody is in the lucky position to do greenfield projects only. Most of us are actually stuck with existing software, like for instance deployment monoliths or other grown systems, and we want to move them, we want to transform these kinds of applications. And I think, especially on the way to microservices, there is some very helpful stuff in the domain-driven design area. And when we take a look at domain-driven design and a lot of, I would say, blog posts, conference talks, or whatever, you might get the impression that domain-driven design is mostly about some of the patterns that we know, like the entities, the value objects, the aggregates, and so on. But domain-driven design itself isn't just about aggregates and entities and services and value objects. I mean, those are very important concepts, no doubt about that. But also here, it goes a little bit deeper, and especially going together, we will see in this talk how domain-driven design helps us in terms of microservices. The book consists of, I would say, 4 really big areas, and 2 of them are really huge. For instance, strategic design and the internal building blocks. And there's also some other chapters like, for instance, the distillation chapter, which very nicely explains how we can distill a core domain from a grown system, which isn't that unsuitable for an idea of extracting microservices out of a deployment monolith. Or the large-scale structure. I mean, every system will grow. I mean, yes, we say microservices should be small, tiny, independently deployable, and so they should be managed by one team and whatnot. But sooner or later, also this landscape will obviously grow, leading to added complexity somewhere. So let's take a first look, at the topic of strategic design first. Strategic design is basically the home of the wholly bounded context, so to say. Which means the bounded context is a very integral part of strategic design. But also the context map with its context mapping patterns. Don't be too worried about not being able to read these small lines down there like share kernel, anti-corruption layer. I will make them bigger in a couple of slides into this talk. Let's start with taking a look at the bounded context. The bounded context is about I would say, the realization that every business domain isn't just a huge big ball of something, some business. It consists of various domains, subdomains, and sub-subdomains, and bounded contexts finally. So we realize that, for instance, when we look at a car, for instance, that I might take as a user of a car, as a driver, a totally different look at a car than the mechanics at the car dealer's shop who are repairing the car, for instance. And each bounded context also has its own model. So there is in every context a certain model. A model consists of entities, value objects, business rules, business logic, maybe some events and stuff like this. And the most important aspect of the bounded context is that it is a boundary for the given meaning of a model. So the meaning of the model is basically only valid inside a bounded context. It may be seen totally different in another context, for instance. Let's take a small example here. We go to a conference. For instance, next week there's the awesome Micro-Exchange conference in Berlin, and people are signing up for the conference. So in order to get the conference up and running, the folks decided, hey, we built some bounded context. The first one is the reservations system. And we have a customer here that wants to attend the conference. And in the reservation system, we might see the customer in a very natural way. So the customer has a name, she has some payment details, an address, a company where they belong to. So that is, I would say, a very natural view on a person or a customer. But on the other hand, if we take at the event management, in the event management, we must be able to deliver a proper event. So we want to know which of the sessions, they have a couple of parallel tracks, do have a very high demand from the audience. So for instance, if let's say Josh Long from the Spring team is doing one of his outstanding talks, the room will be packed. But for instance, another speaker who's doing a great talk as well, but on a very specific, low-level kind of topic, will only draw a smaller interested audience than Josh with his talks. And also, we have people who are eating meat, people who are vegetarians, people who are vegans and whatnot. So the customer in the event management context is basically just a collection of session registrations. So I'm, for instance, interested in hearing a talk by Russ Miles, by Michael Simons, by whomever, and so on. And somebody other is interested in some other sessions, for instance. So I'm not seen as a customer inside the event management system or the bounded context here. The same goes out, I'm also a lunch preference. So I've turned from a person to a lunch preference. So that's the view on the customer in the event management bounded context. On the other hand, in the badges, I mean, everybody who's ever been to a software development conference or to some other conference or some fair or something knows, you usually get one of those lanyards with some nicer or uglier ads on them and a printed badge. And so the poor customer is turning from a lunch preference into a printed badge. So we just know, okay, for everybody, for every registration, we need some kind of a badge. So, and there needs to be a name printed on it, a job description, and for instance, a Twitter handle. And is this seen as a customer? No, not really. It's a badge with some values that are printed on the piece of paper of the badge. So you see, in this example, we see that each bounded context has its own model of a customer. Is it being called a customer in the badges, or is it being called a customer in the event manager? Rather not. But it's like it's a representation of the same person. There is a person sitting here, and the person has a badge, has some payment details, and it has lunch preferences and session registrations and so on. This is actually a really major enabler for independent microservices. So yes, we do accept in this context that we may have redundant data somewhere. So we may replicate some data. I mean, on the one hand, I would say a lot of folks will run away screaming, "Oh my God, this mustn't happen. This is horrible." But on the other hand, other folks who want to continuously deliver software in a very high pace, they may have to sacrifice, like let's say, the central data for distributed data in order to be able to act independently around all these contexts. And there is an interesting thing here. In the badges and the reservations, we have the name, for instance. So there is some sort of a shared view of the customer. And we can make a very educated decision here if we want to have some shared data or some rather centralistic microservice, or if we say, okay, I mean, if my last name is written with a B except for a P, how catastrophic is that? Depends on my temper. So, but in the end, the world won't go down. So if I'm offended by that, they just print another badge, and fair enough. So basically, in this scenario, I would say, we don't need to share data. If there is a hiccup, whatever. If a badge is missing, we print it out at the conference, and it's good enough. I mean, we just have to make sure that not all of the badges are missing, because then we have long lines and people are missing out on talks, and they get really mad then. And putting this into a further context, we have a technique called context mapping. The context map takes into account that an isolated view of a bounded context is of a rather limited value. Okay, we have this bounded context there, this bounded context over there, another bounded context over here. But usually these bounded contexts are talking to each other. So there is some sort of interaction between the bounded contexts. And what we have to be very clear about is that the context map isn't actually a technique or a way of looking at things when you do an upfront design in a greenfield project. It is rather something that you use when you have an existing application landscape or an existing application, and you want to do an analysis of it, how integrated all of these applications or modules or whatever are. So you can basically apply the technique of context mapping to some applications that you have in your, let's say, in your company. You could also apply it to a deployment monolith that has some, let's say, business modules in it. So we deploy a monolith that has, let's say, 10 jar files in it, for instance, a mortgage loan application, and we have a scoring module, we have an application module, we have a credit decision module, we have a payout module, and so on. You can also take a look at these modules, how they interact with each other, how they are coupled with the techniques of context mapping. And I would say, why do I think that context mapping is such a precious tool is the fact that it goes further than a lot of the, let's say, enterprise architecture analysis and drawing techniques that we have. Because what we usually have in, let's say, enterprise architecture diagrams is, we have a system A over there, let's say a credit application system, and we have a scoring system. And credit application is calling a method score credit application on the scoring system. So this is usually where a lot of the analysis in the enterprise architecture field end. But what we do not take into account is what is actually happening with the model of the upstream system and the downstream system. Usually when one system is consuming a model, some service or a REST interface or something else from another system, we label one system as upstream and the other as downstream. Usually the system providing the functionality is called the upstream system, and the system consuming the functionality is called the downstream system. Why upstream, downstream? Take a look at a river. I'm from Nuremberg in Germany, and us Nurembergers, we don't have the best relationship to our neighbor city Fürth, like Frankfurt and Offenbach and Cologne and Düsseldorf and whatever. I mean, you know the games. And there's a river between the two systems. So the river is flowing from one city to the other city. So if the city is that is upstream in the river, is tossing a lot of rubbish in there, or they're shutting down their Kläranlage, sewers, yeah. I mean, all the rubbish gets down to the downstream system, and this is exactly the way you have to see it in terms of the context mapping. So if the upstream system is producing a lot of rubbish in terms of models, there is a risk that the rubbish is going down to the system, consuming the stuff, and also poisoning this model. And this is exactly what the context map analyzes. So it takes into account what is happening with the model of the upstream system in the downstream system, and it also takes into account, let's say, political or organizational topics as well. It's not just technology, it's also a way how teams are acting with each other, how they are behaving with each other. And let's take a look at the context mapping patterns that have been described by Eric in his very nice book, Domain-Driven Design. The first pattern between two systems is the shared kernel. I mean, everybody who ever had a Java application in their hands that used, for instance, RMI or Hessian or whatever, some binary protocol in order to establish a communication between two systems, obviously had a shared kernel, because these two systems had to be binary compatible on the interface. So a very tight coupling. But it's not limited to, let's say, binary protocols. You can also have a shared kernel if you have two systems that are accessing the same rows on the same database instance. I mean, you do an architecture review and they are very loosely coupled. No problem at all. They're just accessing the same tables. Sorry, they are very tightly coupled because they have a shared kernel on the database. You can also, for instance, achieve on a shared kernel on a runtime platform, on time, on whatever. Even on events, if you do a very tight coupling on events, you may run into the risk of having a shared kernel as the event. The next two, the customer supplier and the conformist, basically start off with doing the same thing. They consume a service from a system. So there is a downstream system that is calling some service from the upstream system. And now let's say I have Michael sitting here. He's the provider of the upstream system. And I'm consuming one of his services. The service is called Hand Me a Beer. And in terms of the customer-supplier relationship, I consume the service, but as soon as he wants to change some semantics of the service, or he wants to change some semantic of the model, the interface, or whatever, I have a veto right of doing that. The veto right can be obtained, for instance, due to hierarchies. So I'm ranked higher in a hierarchy as Michael and his team is, and I can say, no, you don't. You don't hand me a Pilsener, you stick to handing me a Weissbier. The other thing is, I am a very aggressive person. What, you want to give me another beer? Okay, we'll do it later on, for instance. Or I am very well networked in the organization. I go, let's say, to heavy metal concerts with the CEO of the company every 2 weeks. So I can say, come on, hey, this Michael, it's changing the model again. Can't you just block that? Yeah, I'll take care of it. Michael, you don't change the model. So that's a typical customer-supplier kind of thing. The next one is totally different. I'm a conformist. So whatever he does, I'm going to consume it. So if he's giving me a Pilsener, I drink my Pilsener. If he's handing me a Radler, I drink the Radler. If he's handing me a shot, I drink the shot. If he's handing me an alcohol-free beer, I drink the alcohol-free beer. It's all I do. And there's also various reasons for this kind of relationship. The one is obviously a political kind of thing. I'm in a very weak position. I'm very new to the organization, so I play it nice and I say, okay, I first take what I get and then I'll see how I sort things out later on. But there is also a very interesting part of being a conformist. When you are consuming, for instance, functionality from custom-off-the-shelf software, for instance, or when you are consuming, let's say, public RESTful services. There is a very nice example for that in which I stumbled into as a, let's say, spare time hacking project. I'm running an online music magazine. It's this one. And in this magazine, people want to have tour dates. They want to know, for instance, where Guns N' Roses are playing this year. They want to know if Metallica are playing a show in Germany this year, and whatever. And but for us as providers of the music magazine, this is a tedious task. The bands send the 2 dates, some labels send them, you get them double. Everybody has a different format, and it's not the most rewarding word typing in tour dates for your readers. You want to write about records, how much you love the new whatever record, how much you dislike the new whatever record, and so on. You don't want to type in tour dates. So we said, okay, we go to an external service. There was one, Last.fm had a very great RESTful API with an awesome model for tour dates. And they also allowed that we were able to store them for a couple of days and build added services on top of it. So since I'm traveling quite a bit as a consultant, I sometimes put out my mobile phone in a city and I know I had time on the evening, concerts close to me. I love that feature, which we implemented on the site. So, but suddenly Last.fm just stopped the service without any notice. Boom. We were stuck without getting no new tour dates. So, since we loved the Last.fm model so much, we conformed to it. The UI was built on that model. We used that model for the persistence. Screw me. That was a greenfield project, but it was just so suitable. It was such a good model, and I was like, that's awesome what they have constructed. And now we were stuck, no new tour dates, and we have to switch to another provider now. So what do? First choice is we have to change everything, like the UI code, the business logic code, the persistence model, and so on. But no, we go for a different way. we have decided that the old Last.fm model is going to be our new internal model, and we introduce an anti-corruption layer. So any new service that we are going to consume, we will put another layer in front of it that is transforming the external model to our new model. I mean, in the easiest way, this can be some tiny bit of a mapping layer, where you just isolate the model translation. On a larger scale, this can even be an independent microservice. I think especially for very, very grown systems in very big companies, centralized systems, you can't just say, okay, we shut them down and rewrite them new from scratch. It doesn't work. And it would obviously be a very bad idea doing that. And what an idea that you can do is that you encapsulate them towards a more modern world with an anti-corruption layer that is, for instance, acting as a facade to a very complex API that requires a lot of business knowledge. You can add some messaging semantics or some event semantics on them that they can react on events and synchronize with the backends. They can establish resilience patterns and so on and so forth. So this can range from a small mapping layer to also an independent anti-corruption layer microservice. The way that we actually want to work in a microservice world is separate ways. Separate ways is we are decoupled on a very high range. I mean, then sometimes you need some sort of an communication. And if you use a very lightweight, event-driven approach of acting between a couple of microservices, you might be able to range that in terms of separate ways because you're very highly decoupled. So I want to reach a very high decoupling between two microservices. And in domain-driven design, this is called separate ways. The other two are, I would say, rather the open host service is a very straightforward thing. Basically, I've been talking a lot about open host services throughout the last patterns. Basically, as soon as a upstream system publishes some functionality through a dedicated interface, let's say a REST resource, a web service, or whatever, we call this an open host service in terms of the integration. And the open host service also often goes hand in hand with the published language, which is, I would say, when you publish an API, when you have an API, you have a certain view on a model that you are propagating through that API. And this view on the model can be seen as a published language. But please be aware, the published language can also be mistaken for, let's say, let's create a general published language over our whole application landscape. I would say that's then the published language Unternehmensdatenmodell. And I think most of us know that the Unternehmensdatenmodell didn't go down very well in a lot of organizations. So please be aware of that and don't overdo this. Let's take a look at an example. Here we have, let's say, an example of an application. And this consists of a credit application. We have a bounding context called scoring. We have a credit agency. We have a credit decision. And we have a CRM system. So they are integrated. And this is usually the way that a lot of people here in the audience have seen some papers printed hanging on some walls. We're calling that one, we're calling this one, and so on and so forth. But in this way, we only see call stacks. We only see who is calling whom. And this is, of course, this is an interesting information, but it gets more interesting as soon as we work with the context mapping technique. Let's first of all mark upstream and downstream systems. So basically, for instance, CRM is an upstream system on the credit application. where credit application is the downstream system. Scoring is a downstream system for the credit agency, and the credit application is a downstream system for scoring, which is then the upstream system in this call hierarchy over there. And then we add some of the context mapping patterns. For instance, the credit agency has a public web service API. So it's an open host service on this side. The same goes out to the credit decision. We also have a web service API. And for the CRM system, which is being integrated through a RESTful resource, RESTful HTTP. And between scoring and credit application, I have a shared kernel. Unfortunately, they are working on a database level together. So they are accessing the same tables on the database, and scoring is just waiting for credit application to be finalized, and so they can score the credit application. So there is a shared kernel on the database between the two. The scoring to the credit agency is a conformist. So for instance, a typical credit agency in Germany is die Schufa. Everybody knows it. And we say in the scoring thing, the Schufa is our model here for scoring results. So we have some percentage, how highly likely it is that the person applying for the credit is being able to pay back the credit. We may get a color, green, yellow, red or something, and we may get some warnings and whatever from the Schufa interface. I'm not sure what exactly they send out, but it's just a guess. And we're conforming to that model in the scoring system. Between the credit application and the credit decision, we have a customer-supplier relationship. Credit application sees itself as a very central team, and we are very powerful, we are very important. Without us, there is not going to be any new credits. And it has established an access, an anti-corruption layer toward the CRM system. Now, the interesting thing here is, I mean, this looks all like, yeah, interesting, but where's the point? Take a close look at the way the models may get propagated all the way down there. Scoring is a conformist on the model of the credit agency. And the credit agency and the credit application and scoring are sharing a database together. So we may run into a risk, or we are in the risk, of having the model of the Schufa in our credit application, which is obviously a bad thing. Because if we say we're dissatisfied with Schufa, they send us, they are too strict, we want a more relaxed credit agency, they are harming our business, we go to somebody else, let's say to whatever agency, and they have a different model. Now, we may see, like from the enterprise architecture drawing, okay, we have to change scoring, that's it. No, mid-term into the project you realize, damn, we have to address the credit application as well, because the model of the Schufa has been propagated down to the credit application. And this is a very valuable insight when you want to transform toward microservices. And this also goes hand in hand with Conway's law. I mean, there is no microservice talk without mentioning Conway's law, as well as there is no microservice talk without mentioning bounded context somewhere. If we take a look at the degree of team communication, we will find out that we have a very tight coupling and a very high degree of communication in the customer, supplier, and conformist thing. The shared kernel, we can basically talk about a team partnership. I mean, they win and they lose together in the shared kernel. And on the anti-corruption layer, separate ways, open host service, we're more or less going towards more of an independence between the teams. Now, that's it for strategic design. Let's take a look at the internal building blocks next. I mean, I would say the internal building blocks have for ages been the most popular and the most well-known and mostly discussed topic in domain-driven design. And they consist of aggregates, entities, value objects, factories, repositories, services. Newer interpretations might also include domain events on them. And let's take the entities out first. Entities are, or another word to the internal building blocks first. They are used to structure and to model the internals of one bounded context. And it's also very important. Please be aware that the context is the boundary for the meaning of a model here. And I will take on that with an example in a couple of seconds. The entities, they represent the core business object of a bounded context. And this is very important, of a bounded context. So we're only taking the context view. Usually I always say, take a broad look, take a look around, look at stuff you don't know. In this case, you say, this is my context, and I only take a look in that context regarding the internal building blocks here. And the typical characteristics of an entity is they have their own life cycle and they have a constant ID. So for instance, a customer, a credit application, a shipment. On the other hand, the value objects are, I would say, supporting models in a context. They are not that important as entities. They don't even have a constant identifier. So I derive an, let's say, a value object or the ID of the value object by the combination of their, let's say, of their attributes that they have. And they don't have an own life cycle. So their life cycle depends on entities that are referencing them. And you should always consider value objects for your model. I would say actually very good models have more value objects than they have entities. And if you take a look at a lot of existing software, excuse me, if you take a look at a lot of existing software, we see a ton of entity here, entity there, and so on and so forth. Why did that happen? Because people modeling them didn't mind the context they're in. So they started, especially in monolithic applications, okay, we need a general purpose model. And the interesting thing on this slide, maybe somebody has realized it. Why did I mention the customer on both of them? Absolutely. The interesting thing is, the customer, is it now an entity or is it a value object? It depends on the context that you are looking at the customer. It always is dependent on the exact bounded context you're in. For instance, in a CRM application, customer relationship model management, the customer is of course a central entity. But for instance, when I am printing badges for a Microservices conference, I don't need the customer to be an entity. The customer is just providing a couple of values to the context, and it's just a first name and a last name on the entity. Another example is when I buy something. Let's say I buy some stuff down in Aachen, and the product that I buy, let's say this purse costs 10 euros or something like that. So is the monetary amount of 10 euros an entity or is it a value object? Obviously, in the context of, let's say, an e-commerce application or an e-commerce bounded context or a pricing system or whatever, is probably a value object because I'm only interested in the value and the currency of the thing. But now when I switch sides, I mean, these are the 10 euros. I mean, I can represent the 10 euros with this 10 euro bill. I can also represent it with 5 2 euro coins and whatever. But if I'm now switching sides and I'm writing a software for the printing of 10 euros at the Bundesdruckerei, it's exactly these specific 10 euros I'm going to talk about. So this 10 euro bill has its own life cycle. If I burn it, it's gone. It has a constant ID. It's XA155 and so on and so forth. So there is please bear that in mind. And it's always dependent on the context that we are in. And also, for every entity that you create in your context, I would raise these questions. Is that really an entity? Or isn't it just a value object? And then we have the aggregate. The aggregate is also, I would say, a very powerful concept. But when you have modeled your bounded contexts very carefully, you will find yourself in a situation where you have the aggregate, but it's mostly derived from some leading entities. And the aggregates, they group entities together. So we have a context that has some entities. For instance, here we have a loan application form, which is a root entity. This one refers to a loan, which is also modeled as an entity. And we have some redemption details on the loan and a self-disclosure on the loan application form. In addition to that, we have a customer and an address. The address is a value object and so on. So the aggregate is basically a grouping around these entities. So we say, okay, that's basically the loan application part of the application. And this is a customer part. And we are propagating some entities to so-called root entities. And these root entities, like the loan application form and the customer, they are more important entities than other entities in the context. And the root entities have the following characteristics. First of all, they are steering the life cycle of the complete aggregate. So basically we are breaking a rule of the entity rules. An entity has its own life cycle, yes, as long as it isn't referenced in a call graph from a root entity, because then the root entity is the chief in terms of their life cycle. And the most important characteristic is basically that you are only allowed to access stuff inside an aggregate through the aggregate's root entity. I mean, this is a reference that is totally okay. Would I go from the customer to the loan, for instance? I want to model a relationship from customer to loans. Hey, what's the loans of the customer that have been applied? That would be illegal, because the loan is just an entity. I would have to go through the loan application form in order to obtain all the loans of the customer. And another hint, I think it's very practical. When you do not model these on a by reference basis. So you wouldn't write a loan application form get customer method. You would have a loan application form get customer number, and then you would explicitly load the other entity. So you would have a by value semantic, not by reference. And then we have some other patterns also in the building blocks, like factories. They take care of entity and aggregate instantiations. I mean, we all know the GOF factory, especially the people writing a lot of code in the audience. There is not a big difference. Repositories encapsulate and represent the data access. And it is also very important that the DDD repository, as domain-driven design sees it, is also including storage and caching. And this is also very interesting in the microservices landscape, because a lot of the opinions in the microservices community say each microservices should have their own storage. We don't go to a centralized storage like the big, huge Oracle databases in a rack or something like that. We would have, for instance, let's say, Couchbase in one microservice, a Neo4j in another, and a Postgres database in another, and for instance, a DB2 in the next microservice. So they all have their own storage as well. And services that implement business logic that relates to more than an entity, more than an aggregate, or that is a very complex logic where you don't want to swamp the model with, so you can extract it out. Now, having talked about the internal building blocks, it's time to take a look. We've done all the stuff. So it's working great. We don't have a big issue. We're continuously delivering value to our customers. And everything grows. So we're getting successful. And we need to scale out these things. And one of the very important things is the evolving order. What is very counterproductive is this guy on this slide here. I call him the chief ivory tower architect. His main skill is PowerPoint. And he's usually tossing out rules like very rigid development guidelines, inflexible architectures, rules and conventions for everything, and a quote from him from a meeting with an external company is, I don't need the expensive folks, I prefer cheap ones because I do all the thinking for them. And this is for instance, if you take a look at the microservices world, how we see basically how we should build microservices. No one says, okay, you need a strict rule set in order to build microservices. Some, I would say, rather extreme folks say every team can independently decide what they want. I would say I would go a middle way. I would say that there needs to be some boundaries, but teams need a way to decide things. I mean, what's the reaction of developers? Let's have a couple of developers commenting on that dude. The system is too complex, we need to dumb down some things, and we need a workaround for that, we need a workaround for that. Damn, he again with his architecture management tools, let's use reflection that we don't get on the radar or something like that for some hacks. And that's not the way it should be. What Eric wrote in 2003 is one quote: let large structures evolve, don't over-constrain design principles. The next thing is, these large structures should be applicable across bounded contexts. So, for instance, you can have a rule that says, okay, it's okay to write a microservice with a JVM language. So you can use Scala, you could use JRuby, you could use Java, for instance, because the ops folks are able to operate the JVM. There's no big deal. You can use Groovy, whatever. But please don't use any non-JVM languages. So this is applicable across many Microservice bounded contexts, and it gives developers a choice, but there's also a boundary that you shouldn't cross. Or you can say, okay, in terms of data storage, you can choose between an Oracle database, which is expensive, you can have a Neo4j, or then we do some key value storage or a document database such as MongoDB. You can choose from any of these without any questions asked later on. If you want to do something else, please go to some of the architects. And that's what I call some practical constraints. And the stuff that Eric Evans wrote down in 2003 is exactly nearly the same like every microservice pitch these days. It's absolutely a perfect fit together. What we can also do is to define responsibility layers, especially if you look at very synchronous microservice landscapes. For instance, that establish a backend for front-end pattern. So you have a front-end microservice, then you have a backend, you have some storage microservices, and you create a certain interface for every front-end in order to optimize latency, user experience, and so on. You group your microservices along some responsibility layers. So basically, you can also have layered microservices that structure your bounded contexts, how they fit together. I mean, this isn't as important when you take the microservice approach of self-contained system, because the self-contained system microservice space already says, okay, build one microservice that addresses one bounded context, and this should be a full stack microservice with user interface, logic, persistence, in one thing. For instance, other microservices styles say, okay, you should have a microservice for every layer, for instance. That's also out there. And this especially addresses these kinds of microservice architectures. And finally, we have the chapter of distillation. In the distillation, I think there is some really interesting hints on how we can extract microservices from a monolithic application. And we should first identify our core domain. So what's the actual core? And we can extract that core and identify the core. And then we create a vision statement. So what is part of our real core domain here? So this vision statement should also focus on the logic that we have, on the business impact. So it shouldn't be, okay, we need an Angular 2 front end backed by some RESTful, let's say, Spring Boot applications that are persisting data to a Neo4j application. I mean, this can be a vision statement for every kind of application. But we can say, okay, this application addresses the scoring of credit applications. It asks a credit agency for their rating and implies that to the actual scoring result, and scoring is also done on with these rules, and these rules. That is a true vision statement. And what is not part of the scoring is, for instance, the final decision of the credit. So we describe what is in there and what is not in there. I mean, everybody in the room who's doing, for instance, some ARC-2042 architecture documentation, this is perfectly a part that can be a part of any software architecture documentation. And the same goes out to the distillation document, because it describes all the details of the core domain. And a very good hint, for instance, for the distillation document, when you start that, just pick up the ARC-42 templates. It's Apache licensed, you can adjust them, and it's a very, very good document for starting out documenting a distillation of a domain from a monolithic thing. And finally, we do that in an iterative basis. So we identify a subdomain, extract it, clean the separation, do some refactoring, and we go on and on and on again, and extract one microservice after another. So looking back to all of these things, I seriously think that microservices do love domain-driven design. I think the concepts together are a very perfect mix. They're fitting very well together, and I must say also from my own experience, for instance, the context mapping thing is, in my eyes, a very, very valuable tool, especially when you have to work with existing software. I mean, we can't deny existing software. It's out there, and it serves a purpose. It earns a lot of money usually, and I don't like these let's say coffee room talks. Oh, we should toss that system away and write it again. You'll probably fail with that. So I think especially the distillation and the context mapping techniques give you a very clear thing where you can say, okay, here we have a quick win. That's easy to separate. Start with that. Okay, we've learned some new things. We think we can separate this other domain, this other subdomain, very cleanly away as well. Go ahead. And with the context mapping technique, you aren't running into a few surprises. I mean, obviously, somewhere down the road, you will run into some surprise, but I think the surprise density gets a little bit decreased here. So, I'm done with my talk. I'm open for questions. So if there's any feedback, any questions, just pass them to me. Just two things. I'll publish a link to the slides in the next time on my Twitter handle @bitboss. And a shameless plug, we from InnoQ offer DDD and microservice trainings and consulting. Then I say thank you very much for having me. It was a pleasure.